Okay, so you're supposed to find the y-intercept. Remember the y-intercept? If I draw my coordinate grid, the y-intercept is anywhere along here, along the y-axis. Anywhere along the y-axis, x equals 0. So I'm looking along here, oh, there's x equals 0. So my y-intercept must be that one, -4. So that's the y-intercept of -4. So this is talking about this graph. So it says, using the data in the graph, complete the table. So here it is at 6 o'clock. If I come across here, that's about 200. 7 o'clock looks like it's right there on that line, so that's 800. 8 o'clock looks like it's right along here, about the middle of that, so that's about 1,400. 9 o'clock looks like it's right about in here, so I come over here, that's between 16 and 2,000, so that's about 1,800. 10 o'clock, I come up, there it is right there, that's between 2,000 and 24, so that's probably 2,200. So I've got my table filled out. Part B, how far did the plane travel between 6 and 8? Well, between 6 and 8 is here, so it went from 200 to 1,400 miles. So it started at 200, went to 1,400, so I can realistically subtract those, and I get 1,200 miles. So that's how I knew what to do. As I said, it went from 6 to 8. At 6 o'clock, it was 200 miles. At 8 o'clock, it was 14. So 14 minus 200 gives me 1,200 miles. What was the plane's average speed between 6 and 10 o'clock? Now, if you think of these as your y and these as your x values, we're going to pick our 2 points, 10 o'clock and 6 o'clock. So we're going to go change in y over change in x. So change in y is 2,200 minus 200. That's y2 minus y1, y minus y. So 2,200 minus 200. That's this point y minus my other point y. So now I'm going to go this point x. So 10 o'clock minus 6 o'clock. So 10 minus 6 is 4. 22 minus 200 is just 2,000. 2,000 divided by 4 equals 500. Now if I go back up here, these were miles. And these are in hours. So this is miles per hour. Okay. So the total distance from London to New York is approximately 5,500 miles. Justify a reasonable arrival time for the plane in New York. So it takes, according to what we just found, 500 miles per hour. So if I divide this by 500, I get that it's 11 hours, because how many 500s will go into there? 11. And each 500 is 11 hours. So I started at 6 o'clock. So let's look at your little clock. Here's 6, 9, 12, 3. I started at 6. I go up here to 12. That's 6 more hours. And then I come on down here to here. 5 more. So that's 11 hours. So 5 o'clock. It doesn't say AM or PM, but 5 o'clock. Let's say that these were AMs. So a reasonable time to get home would be 5 o'clock PM. That's for the plane to touch down. Still has to go through all the custody and all that other stuff. Now in this one, by the time an infant is 1 year old, she will weigh approximately 3 times the amount she weighed at birth. Baby Carly weighed 7.5 pounds when she was born. Give this equation Carly's weight, y equals in terms of her age, x, where x is measured in months. Then it says determine the y-intercept. That's all that you have to look for is the y-intercept. Boom, there it is. That little number out here that's just hanging out by y equals mx plus b. Remember this, y equals mx plus b? That's the y-intercept. We can't have this because that's the x value, not the y value. 7.5 is what this should be, but the y-intercept is 7.5. Number 4, the x-intercept of a line is 3, the y-intercept is 5. Remember we learned how to do this? The x value goes with the x, the y value goes with the y, and we put it as fractions and equal to 1. Use this table of ordered pairs. So there's a table. So if I were to do the slope, y minus y. So I'm going to go the second y, 5 minus the first y, second x minus the first x. So 5 minus 3 is 2, 6 minus 2 is 4, so that's a slope of 1/2, which is positive. Positive slope means left to right, it's going uphill. So I look at A. That can't be it. It's not going uphill. I also look at my points, 2, 3, and 6, 5. Well, this doesn't even go through the point 2, 3, so it can't be that one. This is a negative slope. It can't be that. This one, there's my point 2, 3. My slope is 1/2, 1/2, and there's my points, 6, 5. So there's my answer. Which of the following represents the y-intercept of the linear equation? Well, none of these right now represent the y-intercept. I need to distribute and get the negative out of there. So y minus x minus 4 equals 10. And then I want to put it in the form y equals mx plus b. So I'm going to add this and the 4 to the other side. So I now have y equals x plus 14. Whoa, there's my y-intercept. Remember y equals mx plus b? Well, b is my y-intercept. So which of the following represents the y-intercept of the linear equation? So right there, the first one, y equals x plus 14. Okay. Given y minus 6x equals 5, what is the x-intercept for the graph of the equation? Remember that the x-intercept is when y equals 0, so I just plug 0 in for y. So 0 minus 6x equals 5, so the 0 is not even there. Divide by negative 6, x equals negative 5/6. So x equals negative 5/6, y value is 0. Oh, there it is, A. Using this graph, what is the ordered pair for the y-intercept? Well, where does it cross the y-axis? Right there, at 0, 0. What is the x-intercept? Remember, the x-intercept is when y equals 0, so that's gone basically. So I just divide this by 2. X is equal to 3. That's my x-intercept. X is 3, y is 0. Given the equation y equals 2x plus 7, what is the y-intercept? Well, right there. That's the y-intercept. When it's written in y equals mx plus b, that number is the y-intercept. Given this graph, which of the following is the x-intercept? Well, there it is. 1, 2, 3 points over. The x-intercept is 3. The y value is 0 along there. Oh, A. Ralph is paying for stereo. His payoff plan is shown below. So this drops by 50, this drops by 50, this drops by 50, this drops by 50. What is the x-intercept? Oh, well, remember the x-intercept is when y equals 0. That's the y, that's the x. The y equals 0 right here. So that's 5 when the y value is 0. So now, these are not put in order, so I'm going to hurry and just change the order. So it says she weighed them in air, then weighed them when they were submerged in water. Her results are shown in the table below. What kind of correlation exists between the weights in air and weights in water? So let's just put these in order so it's easier to see. In air, it's 260. In water, it's 200. The next one, 310, 250. 350, 280. So those are all going up. And then 420, 350. So In air, it's going up. In water, it's going up. As it gets heavier in air, it gets heavier in water. So that is a positive correlation because as one of them goes up, or as one goes this way, the other one goes up. So as one goes to the right, the other one goes up. Or in other words, as this one goes up, so does this one. So as your x's, this top line goes up, so do the y's. That's a positive correlation. It's not necessarily something you have to do on your test, but that's just so you know. What is the x-intercept? Again, the x-intercept is when y equals 0. So I come here, oh, there's a y value of 0. So my x-intercept is 2, 0. So given this graph, which of these statements is true about the x-intercept? So here's the x-intercept. There are 0 computers in 1982. So the x-intercept tells us the number of years it took to get 250. No, the x-intercept tells us there were 200. No, the x-intercept tells us there were 0 computers in use in 1982. There we go.